Here we are with more proofs, and now we're going to do parallel line proofs. Remember, the first thing is when you have a statement column and a reason column, what do? If you miss this on the quiz or the test, you number them. It seems silly, but the first step you're going to do is number them. It's very important. Make sure not to leave it out. So if we look at this, here's my picture, and it says that angle 4 and angle 7 are supplementary. So I'm going to say angle 4 and angle 7 are supplementary, and that's given. Of course, I'm abbreviating, you are not. So if angle 4 and angle 7 are supplementary, then I can say that angle 7 and angle 6 are also supplementary. So angle 7 and angle 6 are supplementary, and that's because that's a linear pair. So I've created a linear pair. Remember, our goal is proving that J and K are parallel. Well, now that I know that 7 and 6 are supplementary, I can say angle 4 is congruent to angle 6, and angle 4 is congruent to angle 6 because of congruent supplements theorem. Congruent supplements theorem. Remember, the congruent supplement was like the transitive property and introducing congruency at the same time. So that property is still with us right now. So angle 4 is congruent to angle 6, congruent supplement theorems, and then I can say that J is parallel to K because of the alternate interior angle converse. Bam. All right, that's how I'm going to prove number 1. All right. Take a look at number 2. Try and see if you can do it, and then pop back in here and see if my answers are the same. All right, here we go. So I'm numbering 1, 2, 3, 4. 1, 2, 3, 4. That's my first step. So if I look here, I can see that A and B are parallel, and that's my given statement. So I can even create those arrows. And I can say that angle 2 is congruent to angle 3. And that is a given statement. So angle 2 is congruent to angle 3. All right, so now if I know that these are parallel, and I know 2 is congruent to 3, I know, but because these are parallel, angle 2 and angle 1 are going to be congruent. Angle 1 is congruent to angle 2 because of alternate interior angles. All right? So alternate interior angles, converse. Because they're parallel, then they are congruent. So alternate interior angles converse. And now I can say that angle 1 is congruent to angle 3 because of transitive property. If angle 1 is congruent to 2 and angle 2 is congruent to angle 3, then I can swap the middleman, make it angle 1 and congruent to angle 3, transitive property. All right. Let's take a look at number 3. Again, 1, 2, 3, 1, 2, 3. Hopefully you paused it and then are coming back to look at the answers. So angle 1 and angle 7 is congruent to angle 7. That's my given statement. If angle 1 is congruent to angle 7, I can say that line L and line M are parallel. And they're parallel because of alternating exterior angle converse. And now that I know that line L and M are parallel, I can say that angle 4 is congruent to angle 8 because of corresponding angles. So that was quick and easy on that one. All right, let's look at number 4. Now, think about, well, all right, angle 5 and angle 6 are supplementary. That's given. So angle 5 and, angle 8 are supplementary. Again, I'm abbreviating. You are not. Angle 1 is given. So now that angle 5 and angle 6 are supplementary, I know that line R and S are parallel because of, because of consecutive exterior converse. And now that I know R and S are parallel, 3 and 6 are going to be congruent because alternating interior angles. Okay, notice it's not alternate interior angles converse because we've already proved that R and S is parallel. Because they're parallel, if lines are parallel, then alternating interior angles. So notice when to use converse, when not to use converse. All right, let's take a look at number 5. Again, here we go with the numbering. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So C is parallel to D. That's a given statement. Angle 1 is going to be congruent to angle 7. Angle 7, and that's a given statement. All right, so let's look to C. Angle 1 and 7 being congruent really doesn't tell us much. I know that CD is parallel, so if I know CD is parallel and I know that angle 1 and 7 are congruent, I know that angle 3 is going to be congruent to angle 7. Angle 3, actually, because C and D are parallel, I know that angle 1 is congruent to angle 3, and angle 1 is congruent to angle 3 because corresponding angles. And now I know that 3 is congruent to 7. Angle 3 is congruent to angle 7 because if I look above, I've got this transitive property here. So that's transitive property. And now, because angle 3 is congruent to angle 7, I know that A is parallel to B because of the corresponding angles converse. Okay, so hopefully you see how I got that one. All right, let's take a look at number 6. They're getting longer. All right, so I'm going to hit them up for the numbers. That's my first step before I do anything because I don't want to get points taken off if I don't do that. All right, so here we go. J is parallel to K. That's my given statement. Now, look what we're trying to do here. We're trying to say that angle 1 and angle 7 are supplementary to each other. So when you talk about supplementary, that we're going to have to talk congruency and then bring it back to definitions here. So if angle 1 is congruent to angle 7, I know that angle 5 is congruent to angle 7. So because J and K are parallel, angle 5 and angle 7 are congruent because corresponding angles. Not converse, just corresponding angles. Eventually, I'm trying to prove that 1 and 7 are supplementary to each other. All right, so now I know that angle 5 and angle 7 are congruent. I can say 1 and angle 5 are supplementary. Angle 1 and angle 5 are supplementary. Why can I say that? Because definition of linear pair. All right. Definition. Oh, you know what? Whoa. Hang on. Oh, I'm missing a silly step. I can't say that they're supplementary unless I take away that congruency. So I need to say the measurement of angle 5 is equal to the measurement of angle 7, and that's that definition of congruence. So make sure you have that definition of congruence first, because now I can say that angle 1 and angle 5 are supplementary. But I had to take off and get that measurement first, and that's a linear pair. I had to go from congruency to take it down to measurement, where we're not just talking about angles. So now I can say the measurement of angle 1 plus the measurement of angle 5 equals 180 degrees, and that's definition of supplementary angles. And now I know, look what I'm trying to prove, that angle 1 and 7 are supplementary. Here I am at angle 1 and angle 5, And I know the measurement of angle 5 is equal to the measurement of angle 7. So now I'm going to say the measurement of angle 1 plus the measurement of angle 7 is equal to 180 degrees. And why? Because I'm substituting angle 5 and angle 7. So that's substitution. And now I can reverse the adding and say that angle 1 and angle 7 are supplementary. And my reasoning is definition of supplementary angles. So remember, definition of supplementary angles tacks on the measurement and puts it equal to 180, and then it allows me to take it off. Remember that? All right, so that's number 6. Let's see how we do on number 7. Oh, so a longer one. All right, here we go. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. All right, so let's start out, and I have that AB, line AB, is parallel to line CD. So that's given. I have the measurement of angle ABC is equal to the measurement of angle ADC. So what I'm going to do is I'm going to mark it. ABC, because when they do this, it's kind of hard for me to see, is equal to the measurement of ADC. So these two guys are congruent to each other. I know that these lines are parallel right here, so that allows me to make a lot of statements. Eventually, I'm trying to prove that AD and BC are parallel. But now that I know these guys are parallel, I got a lot of room that I can say. I can say that the measurement of angle ABC is going to be equal to the measurement. No, that's not what I'm going to say. That's not what I'm going to say. I'm going to say that DAB and CDA are supplementary. DAB and CDA are supplementary, and that's consecutive interior angles. So let's mark that. And CDA are supplementary, and so that's consecutive interior angles. All right, so let's take a look at number 4. I can now say that the measurement of ADC and the measurement of CDA, measurement of DAB and the measurement of angle CDA are equal to 180. Let's put a plus there. And that is your definition of supplementary angles. I'm sorry if my writing is bad. That's my definition of supplementary angles. Okay, DAB and CDA. All right, ADC. Okay, so on number 5, I am going to substitute ADC and I'm going to DAB I'm keeping. I'm sorry, I can't read my writing. I'm substituting ADC for ABC. So now I can say the measurement of angle DAB plus the measurement of angle AD. I'm lost. DAB. Okay, DAB and ABC, sorry, is equal to 180. There I go, because I'm substituting in these guys. There it is. Substitution. All right, and then on 6, I can say that now DAB and ABC are supplementary angles. BC are supplementary angles, and that's definition of supplementary angles. And now I can say that AD is parallel to BC because of the converse statement of consecutive interior angles. Consecutive interior angles converse Oh, that was ugly. All right. So hopefully you're getting more practice with these, and then we'll hit up video 2 for part 2 with more proofs. Good luck.